Now, we've already looked at the quadratic formula this year, so I'm not going to do more than 2 examples right now, but if you end up having questions, let me know. If you remember, the standard form of a quadratic equation is y equals ax squared plus bx plus c. So even if they move the order around or whatever, a is the coefficient of the x squared term, b is the coefficient of the x term, and c is the constant when all of my terms are on one side of the equation, with 0 on the other side or y on the other side. And then this, as a reminder, is what the quadratic formula looks like. So the first thing I want to do is to get everything on the same side of the equation. So 4x squared minus 8x minus 2 equals 0. Because this other side of the equation is 0, I could divide everything here by 2 to make the number smaller. I won't in this case. So x equals big long fraction bar. The opposite of b, well, b is negative 8, so the opposite of that is positive 8, plus or minus the square root of b squared, which is negative 8 squared. If you're going to write that, you need to write the negative 8 inside parentheses with the square on the outside, or otherwise you're writing the opposite of 8 squared if you don't write the parentheses. But because I'm squaring the number, it really doesn't matter whether it started as a positive or a negative, and it's just easier to write 8 squared minus 4 times a, which is the coefficient of the x squared term, so 4, times c, which is the coefficient, or sorry, which is the constant, so negative 2, all over 2 times a, which is 2 times 4. Now what I'd like to see as minimum work is go ahead and do 8 squared minus 4 times negative 2, and you get 96. So out to the side, I'm just going to write the square root of 96. Then, to save myself a little bit of writing, this now becomes two different equations. 8 minus the square root of 96, since 96 is not a perfect square, divided by 8 is one of my x's, and x equals 8 plus the square root of 96 over 8 for the other one. When you punch this in your calculator, don't forget to punch 8 minus the square root of 96 equals before you divide by 8. And then round your answer to 3 decimal places unless it specifies otherwise. So x equals negative 0.225 here, and x equals 2.225 here. As a reminder, what this means is one of two things. If I graph the quadratic equation y equals 4x squared minus 8x minus 2, that parabola will cross the x-axis at these two locations. The other way is, because this was set up this way, if I graphed two equations, y equals 4x squared minus 5x, which is a parabola, and y equals 3x minus 2, which is a line, those two would have intercepts. They would intersect each other at two different places. One where x is negative 0.225. That's not on the x-axis, though. And one where x is 2.225. And then if I wanted to find the y values associated with those two places of intersection, then I would plug that into probably the 3x plus 2 would be easier to find my y's. Here, I put these in a reversed order, sort of mixed them around, just to make sure that you're paying attention to the fact that they're not always written in the correct order. So A is 12, B is 7, and C is negative 10. So x equals, big long fraction bar, opposite of B, so opposite of 7 is negative 7, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Now, again, I'm going to plug this part into my calculator, and it turns out this is the square root of 529, and 529 is a perfect square. So I'm going to go ahead and square root it as I move to my next step. X equals negative 7 minus 23, which is the square root of 529, over 24 is one of my solutions, and x equals negative 7 plus 23 over 24 is my other solution. Going ahead and plugging these in and simplifying, I get x equals negative 1.25 and x equals 2/3. You're only rounding to 3 decimal places if you have to. You can give this as a rational answer of 2/3, so you need to give that exact answer when you can.